Well, I went to pause the video on the last one and press the wrong button, so I'm starting over with a new one. So we're going to pick up with number 7, compute the integral using long division. Okay, and maybe that's a good actual natural stopping place because that would have been all examples of partial fractions, and so that might be kind of good as a self-contained video. All right, so x minus 10 over x plus 10. We need to use long division first, but this is one we can use synthetic on. So I'm going to go over here and I'm going to say, okay, x minus 10, that's 1 and negative 10, and I'm going to divide that by x plus 10, which means I need to leave a negative 10 out there, drop this down, multiply, add. Right, okay, negative 20. All right, and so if I divide x by x, that's going to be 1. So this equals the integral of 1 minus 20 over x plus 10 dx. And this is not so bad. This is going to be x minus 20 natural log absolute value of x plus 10 plus c. Number 8. This one definitely counts as long division as well. I'm going to say x to the 5 divided by x to the 2, that's x to the 3. Negative 8x to the 3 divided by x to the 2 is going to be negative 8x to the 1. And then 2 over x squared, I might write that as 2x to the negative 2, and that's what I'm going to integrate from 1 to 2. Okay. Now, with this 2 over x squared, that antiderivative is not going to be 2 natural log absolute value of x squared, right? We need to use the power rule. So I rewrote it as x to the negative 2 to help remind me of that. So it's going to be 1/4 x to the 4 minus 4x to the 2 minus 2x to the negative 1. So x runs from 1 to 2. So I'm going to plug in 2, and I'll have 2 to the 4 is 16 over 4. Minus 4 times 4 is 16. 2 times 1/2 would be 1. Okay, and then when I plug in 1, I'll get 1/4 x to the 4th is a 1/4 minus 4 minus a 2, because any power of 1 is going to equal 1. Now, we could stop there, but, you know, if this was a multiple choice problem, which it almost certainly would be, we would need to simplify our answer. So I'm going to say that's 4 minus 16 minus 1 minus 1/4 plus 6. Okay, so I've got 10 minus 16 is negative 6, negative 7 and a quarter. Okay, pretty sure that's what that's going to be. Number 9 here with this 3x plus 1, this is one that I'm going to recommend that we not use synthetic division on. It's just like kind of one more thing to worry about, so I'm just going to do 48x to the 2, 0x to the 1, and 0 divided by 3x plus 1. Okay, I think to myself, what do I multiply 3x by to get 48x squared? That'd be a 16 and 1 power of x. So I'm going to multiply that down here and get 48x to the 2 plus 16x. Ooh, that's rough. I didn't see that one coming. I thought there was going to be a better quotient. I thought I'd checked it. Oh well, that's just how that goes. And then we go through here, we're going to subtract that, and we'll get negative 16x plus 0. What do I multiply 3 by to get negative 16? Really, it's going to be negative 16 thirds. Okay, and multiply that in, I get negative 16x minus 16 thirds. That's going to be the remainder. Anyway, I subtract that away, and I just get 16 thirds. Okay, pardon me for that. So I'm going to get 16x minus 16 thirds, and I'm also going to check this and make sure I didn't do something wrong here, because I feel like it's kind of weird that that's the same as the remainder. Let's see why it wouldn't be, though. Okay, so anyway, plus 16 thirds divided by, maybe I should write that differently, divided by the original denominator, which is 3x plus 1. Okay, do the power rule. remember to divide by that 3. Okay, let me go check my long division. Yeah, yes, great. Confirmed by Wolfram Alpha. So that was a weird one. I just don't think I thought that. I think I was trying to think through what was going to happen when I long divided that, and I didn't think about the remainder term or something. Or really anything past the first step, maybe. Then number 10, if we're dividing by x plus 3, though, this will be nice. We can use synthetic division. Okay, so this is going to be the integral from 0 to 4 of 4 plus 3 over x plus 3. And that's going to be 4x plus 3 log of x plus 3. X going from 0 to 4, so that'd be 16 plus 3 log 7 minus 4 zeros plus 3 natural log of 3. Alright, and you could say that's 16 plus 3 natural log of 7/3 if you liked, but that's that's about as far as I'm going to take it. I don't know why you would want to take 7/3 to the third power. So that'll be all for that one. This antiderivative here, this is a pretty standard one, quadratic that doesn't divide by x plus 3. X plus 3 isn't clearly not going to be a factor of the numerator. So I'm going to do the synthetic division over here. 1 minus 2 minus 5. I divide that by x plus 3, so I put a negative 3 there, drop it down, multiply, add, let me check. Okay, one way you can check that is I could plug negative 3 into the numerator, and I need to get 10, so it's going to be 9 plus 6 is 15 minus 5 is 10. Okay, that's the, I forgot what it was called, but when we taught college algebra, that was a relevant theorem. The factor theorem or something. That if it's a factor, then it's a 0. The equivalent fact is that the remainder that I get over here should be the value of the numerator when I plug in the thing I'm supposed to be plugging in. Anyway, so now I've got x minus 5 plus 10 over x plus 3. That antiderivative is 1/2 x squared minus 5x plus 10 natural log of the absolute value of x plus 3 plus c. And then number 12 kind of looks like the same story. We're going to do some synthetic division off to the side, except I guess this one's a definite integral. So x minus 2, 6, 12, 8, 16. Is that right? Okay. 6, 12 minus 4 is 8, minus 2 is 16. Okay, so 16 and 11 is 27, so I think that would be negative 11. Okay. 6x plus 8 minus 11 over x minus 2. Then 3x squared 8x minus 11 natural log of the absolute value of x minus 2. X going from 0 to 1. This is one where the absolute value will actually be necessary. So 3 plus 8 minus 11 natural log of the absolute value of negative 1. Well, that's the natural log of positive 1, and the exponent I put on e to get 1 is going to be 0. So it's going to be 11 zeros. Minus, when I plug in x equals 0, I would get 0 plus 0 minus 11 natural log of the absolute value of negative 2. So I'm going to have 11 plus 11 natural log of 2. Okay, and 2 to the 11, that's maybe a little bit beyond the arithmetic we might need to know here. But not by much. 2 to the 10 is a number that's going to come up when we do our work with series later. But we'll cross that bridge when we come to it. I think since I cut the other video short, I'm going to cut this one too, since these were all long division integrals. So that's going to be all for this one. Thanks for watching.